Hello viewers, in today's class we are going to discuss an important problem from differentiability of a function, right? So here we are given a function f of x which is equal to x square times mod of cos pi over x for x not equal to 0, and here x belongs to the set of real numbers, and f of x is equal to 0 when x is equal to 0, right? And here we have to test the differentiability of this function at this point x is equal to 2, right? So here f of x is given as 0 when x is 0, and for other values of x, that is except x equal to 0, the function is defined like this, right? So let us start. Now we know that a function is said to be differentiable if the right hand derivative and the left hand derivative both exist and finite and are equal, right? So the definition of differentiability says that the right hand derivative at the given point, here the point is given as 2, x is equal to 2, so the right hand derivative, which is defined as limit h tends to 0, f of x plus h minus f of x divided by h, and the left hand derivative is defined as limit h tends to 0, f of x minus h minus f of x and minus h. So a function is said to be differentiable at some point, here the point is given as 2, if the right hand derivative exists and finite, the left hand derivative exists and finite, and the right hand derivative is equal to the left hand derivative at the given point, right? So here we have to test the differentiability of this function at x equal to 2. So let us find the right hand derivative at x is equal to 2 and the left hand derivative at x is equal to 2, and let us see how we get the values of right hand derivative and left hand derivative, right? So let us first find the right hand derivative. So now viewers, here the point is given as x is equal to 2, so the right hand derivative at x is equal to 2 is denoted by say r of f prime of 2, right? So this notation may be used, but we'll prefer this notation, right? So the right hand derivative is now given by the limit h tends to 0 f of x plus h. So here x is 2, so we have 2 plus h minus f of 2 divided by h, right? Now limit h tends to 0, f of 2 plus h can be written from this definition of f of x. So here we'll put x is equal to 2 plus h. So now we have 2 plus h whole square and mod of cos pi over 2 plus h, and minus f of 2 is written as by substituting x is equal to 2 over here. So we have 2 square and mod of cos pi over 2 and divided by h, right? So now we have limit h tends to 0, this is 2 plus h whole square, and here we have mod of cos pi over 2 plus h, and here we have 0 because cos pi by 2 is equal to 0, right? And divided by h, right? Okay, now here let us see the value of mod of cos pi over 2 plus h, right? See here, we have the mod function, and see this fraction, that is pi over 2 plus h, is less than pi over 2, right? So this angle pi over 2 plus h is less than pi over 2, so therefore this angle, that is pi over 2 plus h, it lies, or it belongs to the first quadrant, right? So this belongs to the first quadrant, and in the first quadrant cos function is positive, right? So now we can write limit h tends to 0. Here we have 2 plus h square, and we have here plus of cos pi over 2 plus h, and divided by h, right? So here this point is very important, because this fraction pi over 2 plus h is less than pi by 2, that is 90 degrees, right? So this angle is less than 90 degrees, and any angle which is less than 90 degree, it belongs to the first quadrant, and in the first quadrant the cosine function is positive. So that's why when we remove this absolute value sign, here we'll have a positive sign, right? So now viewers, here we can further simplify it by writing limit h tends to 0, 2 plus h square over h. This h is this one, and here we have cos of pi over 2 plus h, and if we take pi over 2 plus h as theta, then this term is cosine theta, and cosine theta can be written as sine of pi by 2 minus theta, right? So here we can now write sine of pi over 2 minus theta, and for theta we have pi over 2 plus h, right? Okay, so now we have this expression, and now we can further write it as limit h tends to 0, 2 plus h whole square over h, and if we simplify these two terms, we'll have pi and 2 plus h minus 2 over 2 times 2 plus h. So this 2 and 2 get cancelled, so we have pi h over 2 times 2 plus h, right? So now we have sine pi h over 2 times 2 plus h, right? Now viewers will convert this term, that is sine of pi h over 2 times 2 plus h, in the form sine theta over theta, right? If we take theta as pi h over 2 times 2 plus h, then in the next step we can write, see here, we can write limit h tends to 0, 2 plus h whole square over h, and sine pi h over 2 times 2 plus h, and divided by, see, we have to convert this term in the form sine theta over theta, because we know that limit theta tends to 0, sine theta over theta is equal to 1, right? So what we will do here, we'll write pi h over 2 times 2 plus h, and we'll multiply it by 2 times 2 plus h over pi h, right? So in order to neutralize this term, we have to multiply it by its reciprocal, right? So now viewers, here we see that this limit can be written as limit h tends to 0, 2 plus h whole square over h, and we can take this pi h to the numerator. We can write it as pi h over 2 times 2 plus h, and we have limit h tends to 0 sine pi h over 2 times 2 plus h divided by pi h over 2 times 2 plus h, right? So now this limit is identical to this limit, right? So the value of this limit is 1, and here we have h and h get cancelled, and we have limit h tends to 0. Here 2 plus h and 2 plus h get cancelled, and we have one factor of 2 plus h over here, and here we have pi over 2, right? And this limit becomes 1 because limit theta tends to 0, sine theta over theta is equal to 1. So here this whole angle is taken as theta, so sine theta over theta. Now here if we take h equal to 0, so we have 2 plus 0 pi over 2, and now we have 2 times pi over 2, so 2 and 2 get cancelled, and we are left with pi, right? So the right hand derivative of this function at x equal to 2 is given by this value pi, right? Now let us find out the left hand derivative. So now the left hand derivative at this point x equal to 2 is given by this limit, and we can also use this notation here, and now we can write it as limit h tends to 0 f of 2 minus h, because x is equal to 2 here, and we have f of 2 divided by minus h, right? Okay, so now we have to find the value of f of 2 minus h, and we can obtain this value by substituting here x equal to 2 minus h. So as we have done in the previous step, we have here 2 minus h square mod of cos pi over 2 minus h, and then we have f of 2, so this is 2 square mod of cos pi over 2 and divided by minus h. Now here we have limit h tends to 0, 2 minus h square. Now viewers, here let us take a close look at this expression. See, pi over 2 minus h, this angle is always greater than pi over 2, right? So it means pi over 2 minus h is greater than 90 degrees, and this shows that this angle, it lies in the second quadrant, right? In the second quadrant, and in the second quadrant cosine function is negative, right? So therefore the value of cos of pi over 2 minus h is negative, right? So when we remove this absolute value sign, we'll have a negative sign, and we have cos of minus cos of pi over 2 minus h, right, due to the definition of absolute value function, and this term becomes 0 because cos of pi over 2 is 0, right? And here we have minus h, right? So once again let us see this concept once again. So here we have pi over 2 minus h. Pi over 2 minus h is greater than pi over 2 because here the denominator is less than 2, because here we are subtracting h from 2. So this angle is greater than pi over 2, hence it lies in the second quadrant, and in the second quadrant the cosine function is negative, so the value of cos pi over 2 minus h is negative, hence the mod of, or the absolute value of cosine of pi over 2 minus h is negative, right? Okay, so now we have limit h tends to 0, 2 minus h square, and here we can take this negative sign over here, and we have cos pi over 2 minus h, and here we have minus h. Now this negative sign and this negative sign get cancelled, and we have limit h tends to 0, 2 minus h square over h, and cos of pi over 2 minus h, right? Now we have to evaluate this limit. So now viewers, here again will make use of the same argument. See here, if we take pi over 2 minus h as theta, then this term is cos of theta, and cos theta can be written as sine of pi over 2 minus theta. So now this limit, that is the left hand derivative, can be written as the limit h tends to 0, and we have 2 minus h square over h, and this term can be written as the sine of pi by 2 minus theta, and for theta we have pi over 2 minus h, right? Okay, so now we have limit h tends to 0, 2 minus h square over h, and we have sine of, if we simplify these two terms, we'll get pi 2 minus h minus 2 over 2 times 2 minus h. This 2 and minus 2 get cancelled, so we have minus pi h over 2 times 2 minus h. So here we have minus pi h over 2 times 2 minus h, right? Now we know that sine of minus theta is equal to minus of sine theta. So in the next step we can take this negative sign outside, so we have minus limit h tends to 0, 2 minus h square over h, and we have sine of pi h over 2 times 2 minus h, right? Now viewers, will convert this term as sine theta. See, if we take this angle as theta, we have sine theta, and we'll try to convert this term in the form sine theta over theta, because limit theta tends to 0, sine theta over theta is 1, right? As we have done while finding out the right hand derivative. So now we have limit h tends to 0, 2 minus h square over h, and we have sine of pi h over 2 times 2 minus h divided by pi h over 2 times 2 minus h multiplied by 2 times 2 minus h over pi h, right? So what we have done, we are trying to convert this term as sine theta over theta. So for this we have this term, and to neutralize this term we are multiplying it with its reciprocal, right? So now taking this pi h to the numerator, we have limit h tends to 0, 2 minus h square over h, and multiplied pi h over 2 times 2 minus h, and we have limit h tends to 0, sine pi h over 2 times 2 minus h over pi h 2 times 2 minus h. Now this limit is equal to 1 because of this formula, and here see h and h get cancelled, 2 minus h and 1 factor get cancelled, so we have minus limit h tends to 0, 2 minus h multiplied by pi over 2, and here the value of this limit is 1. And now if we take h equal to 0, here we have 2 minus 0 times pi over 2, and this is minus 2 times pi over 2, and 2 get cancelled, and we are left with minus pi, right? So viewers, here we see that the left hand derivative of this function at x equal to 2 is minus pi, right? And this is quite clear that the right hand derivative is pi and left hand derivative is minus pi, and both the derivatives, that is right hand derivative and left hand derivative, are finite and they exist, but they are not equal, right? So pi is not equal to minus pi, hence we conclude that this function f of x, which is defined by this expression, is not differentiable at x is equal to 2, right?